Hello there. In today's lesson, we are going to talk about completing the square. The objectives that we aim to learn are to understand the technique of completing the square and to properly use said technique. The prerequisites necessary for a successful progression in today's session include a solid understanding of real numbers, proficiency in real number operations, and familiarity with notable identities. Let's get started. Given a certain function f to ax squared plus bx plus c, which is a polynomial of degree 2, we wonder how could we draw it. A polynomial of grade 2 that we all know how to draw is the polynomial x squared, which, as we already know, has a vertex in the point, r0, 0. Given another parabola, that is to say, given another polynomial of grade 2, we do know that said parabola could have the same shape, either looking up or down, depending on the sign of the coefficient a. But when the given expression of the polynomial of grade 2 is given in terms of ax squared plus bx plus c, sometimes we do not know how to identify with enough accuracy where the vertex of the new parabola actually is. To be able to find that vertex and height of said parabola is crucial. This way you can get, given this function of x, its graph, to be able to find an expression of the shape that we just saw up there. Function of x equals to a multiplied by x minus x0 squared plus I0. What we are saying here is that our parabola will have its vertex right at the point of coordinates x0 and 0. If we notice that the x0 that subtracts from x is the horizontal translation and the I0, the vertical translation of the parabola. Our parabola will then be more open or more closed, depending on the value of a, and also if it changes the sign, the parabola will be upwards, or as I said before, downwards. But what we are truly interested in is knowing how to calculate x0 and 0 in general. Let's start by taking our function of x, which equals to ax squared plus bx plus c, and we represent it. What we are looking for is simply the vertex. We would have the vertex on this point right here, x0, which, as we see, is a minimum of the function. In order to find said minimum, what we have to do is find the critical points, which we know are obtained by solving the equation the derivative of f is equal to 0. We set up the equation derivative equal to 0, and we solve it, and it tells us that that vertex will be at the point x0 equal to minus b divided by 2a. After obtaining x0, our focus shifts to I0, which is essentially the value of function of x0. We perform the computation, finding I of f of x0, and then we substitute I0 into the equation for f. After some simplification, we arrive at the number highlighted in blue, c minus b squared divided by 4a. Well, we already have x0 and I0, and this means that we can already write down the formula, function of x equal to a multiplied by x minus x0 squared plus I0. Learning this formula might not be the most practical at times. So we are going to see now an example of how to use this formula and also another practical method to deduce the same expression without the need to know said formula. Let's get into it. First, we are going to see an example of the application of the formula. We take a polynomial of function of x, 2x squared plus 3x plus 1. And applying the formula in this case is just as simple as substituting 2, which is the a, by x minus b divided by 2a, minus 3 divided by 2 multiplied by 2, all of them squared, plus c, which is 1 minus b squared, that is 3 squared divided by 4a, in other words 4 multiplied by 2. And once we have substituted the values of the formula, the only thing left is to simplify. Let's start organizing by leaving the 2 out. The minus 3 divided by 2 multiplied by 2 is minus 3 divided by 4. Both minus signs become a plus, then 3 divided by 4 squared plus 1 minus the 9 divided by 8, which is obtained from the last fraction. 1 minus 9 divided by 8 comes as minus 1 divided by 8, and there we would have our completing the square. Well, as I said, once you know the formula, getting this result is direct. However, many times the formula is a bit too complicated and sometimes we are not able to recall it. So it is a good thing to have a technique that allows us to deduce it quickly. Let's take a look at this technique with the following example. we take the same polynomial, 2x squared plus 3x plus 1. And what we are going to do is the following process. First, we take the coefficient of the polynomial, which in this case has a highest degree coefficient of 2. Next, we factor out in a way that the polynomial becomes x squared plus 3 divided by 2 multiplied by x plus 1 divided by 2. Once we are done with this process, I write the whole polynomial. And now I leave a little gap between the second and the third addend. What am I going to do now? Well, now I will take the coefficient of the x. In other words, the linear coefficient, in this case, plus 3 divided by 2. And I will divide it by 2, which results in 3 divided by 4. And I will end up raising it to the square. 9 divided by 16. After that, what I do here is to add and subtract the 9 divided by 16. Well, once we have arrived here, if we are sharp enough, we should notice that these three first addends are exactly the square of x plus 3 divided by 4. What exactly is that 3 divided by 4? Well, as we see in the slides, the 3 divided by 4, that was appearing at the very beginning above. And the second addend is simply numbers that we can simplify by sorting the fractions out. In this case, minus 9 divided by 16 plus 1 divided by 2, which would be the same as plus 8 divided by 16. And now, the very last step would be taking the 2 we have left, which is multiplying the two addends and dividing it. First, it multiplies the first factor and then multiplies the second factor. In the first factor, we will leave it as it is. And in the second, we will just simplify it. 2 multiplied by minus 1 divided by 16, which ends up becoming minus 1 divided by 8. As we see, we have obtained exactly the same square completion, the exact same result. This procedure that we have just seen is more mechanical and repetitive than the previous one, which is based on the specific steps of the formula. Well, that's all for today's lesson. From now on, we should be able to perform the process of completing the square using the provided formula. Additionally, we can also apply a more mechanical method to complete the square. Finally, we should be able to graph any quadratic polynomial. Thank you so much for attending today's class. See you in the next one.